The chronological flow and branching of autism causes autism, as a complex neurological disorder, stems from the interplay of genetic, epigenetic, and environmental factors. Its causal chain can be traced from fundamental DNA damage and epigenetic modifications, through metabolic disruptions, to specific mechanisms such as mitochondrial dysfunction, ischemia, blood-brain barrier (BBB) permeability, and ultimately neurological imbalances. Each of these points branches out and impacts subsequent processes, making the development of autism cumulative and causally interlinked. One starting point, DNA damage and epigenetic mechanisms, epigenetic processes, such as DNA methylation and histone modification, allow the body to adapt to environmental changes without altering the core genetic structure. However, DNA damage caused by toxins, inflammation, or nutrient deficiencies disrupts this delicate regulation, cause industrialization and increased exposure to heavy metals, pesticides, and microplastics. Consequence, improper DNA methylation hampers the expression of genes crucial for neurological development. Further branching, damaged DNA transitions into mitochondrial dysfunction, heightening the organism's sensitivity to metabolic stress. 2. Impaired DNA methylation and folate cycle disruption. DNA methylation relies on the availability of folate, vitamin B12, and other essential substances. When these nutrient reserves are depleted, or the methylation process is disrupted, cause poor nutrition, genetic mutations like mTTR, and chemical imbalances. Consequence, gene expression dysfunction impacts the immune system and nervous system development. Further branching, methylation imbalances lead to mitochondrial dysfunction, increased oxidative stress, and metabolic issues. 3. Mitochondrial dysfunction. The core of metabolic issues. Mitochondria are vital for energy production and cellular detoxification. When they malfunction, cause inherited mutations, toxin exposure, and oxidative stress. Consequence, energy deficiency impairs neuronal function and causes neuroinflammation. Further branching, mitochondrial dysfunction triggers localized ischemic processes and compromises the blood-brain barrier. 4. Ischemia and inflammatory responses. Ischemia, reduced blood flow to brain regions, increases the risk of neuronal damage. Concurrently, inflammation exacerbates damage to brain cells and structures, cause mitochondrial dysfunction and impaired circulation. Consequence, chronic inflammatory responses compromise the structural integrity of the blood-brain barrier (BBB). 5. Blood-brain barrier (BBB) permeability. The BBB acts as a protective layer, preventing harmful substances from entering the brain. When its function is disrupted, cause inflammation, oxidative stress, and toxic influences. Consequence, toxins, microglia, and immune markers enter the brain, exacerbating neuroinflammation. Further branching, toxin and metal ion infiltration initiates calcium accumulation and synaptic dysfunction. 6. Calcium accumulation and synaptic dysfunction. Excessive calcium buildup in neurons disrupts synaptic function, directly affecting neuronal plasticity and signaling. Cause dysregulation of calcium channels due to oxidative stress and ischemia. Consequence, synaptic dysfunction hinders communication between brain regions, contributing to autistic symptoms. Further branching, prolonged synaptic dysfunction leads to lasting neurological damage. 7. Final outcome, neurological and cognitive symptoms. All previous branches, from DNA damage to synaptic dysfunction, culminate in the manifestation of autistic symptoms. Challenges in social communication, stereotyped behaviors, and sensory hypersensitivity. Cognitive imbalances and reduced flexibility in thinking. These manifestations are not the result of a single cause, but a complex web of interconnected biological and environmental factors. Conclusion: the development of autism can be understood as the result of a cause and effect chain, beginning with DNA damage and epigenetic processes, through methylation and mitochondrial dysfunction, and culminating in neurological symptoms. Each point in this chain branches into intricate mechanisms, each contributing to the final picture. Understanding these interdependencies paves the way for precise diagnostics, prevention, and treatment of autism, with a particular emphasis on an individualized approach to care.